Hello there, students. This is a help video over the class notes packet 8-13I, page 3. The first reaction we're looking at on page 3 is when an active metal can replace hydrogen on a water molecule. If the metal is above hydrogen and it's a very active metal, what that metal can do is cause an H plus to break off the water molecule. So what we're seeing here is potassium, which is a very active metal, can actually knock a hydrogen off the water molecule. It can knock the hydrogen ion off the water molecule, leaving behind an OH minus. Then the H plus, the hydrogen ion, which we have learned is really a proton, it will have an electron from potassium forced onto it. And that's what we could have happen in this particular reaction. In the second one, write the single displacement reaction between magnesium metal and water. First, we have to look on our activity series. Magnesium is a very active metal. It is above hydrogen on the activity series, and it is active enough that it can actually replace hydrogen on the water molecule. So here comes magnesium. It's going to replace the hydrogen. Remember, H2O is essentially HOH. So what happens here on the HOH is magnesium replaces the first H, and it will be together with the OH. Two hydrogen ions are knocked off two separate water molecules, and this magnesium will force an electron on each of those water molecules, or on each of those hydrogen ions. So now the hydrogen ions will both have one electron, and they will join up to form H2. The next reaction we're looking at is not involving metals replacing metals or metals replacing hydrogens. What we're now looking at are halogens, active halogens replacing less active halogens in solution. Here's our halogen activity list. Fluorine's most active, iodine is least active, as we can see here on the list. So what we're seeing in this reaction right here is fluorine being bubbled into a solution containing sodium and chloride. Fluorine is more active than the chlorides, so fluorine will end up pulling electrons off the Cl minuses and be left in solution as F minus. So here's a drawing illustrating what is happening here. Here's the F2 being bubbled in. This F and this F are actually not in the drawing. When you look at the answer key, you'll see that the F's aren't actually there. I just did a bad job of erasing. My apologies. But we have F2 being bubbled into an aqueous solution of sodium chloride. Aqueous means water's pulled apart this salt into the Na pluses and the Cl minuses. There's a 2 in front, so we'd have 2 Na pluses, 2 Cl minuses. F is being bubbled in. These F's again are not here. So now we have F and F in water. When a halogen is more active than another halogen, what it means is it can pull electrons off the less active halogen. So this is a Cl minus right here, and this is a Cl minus right here. And the electrons are being pulled off. Please make sure you put a minus on each of these chlorides, because they are minus as they are over here. Each of these chlorides are minus, and that minus electron is pulled off by the fluorines. So now each of these chlorides are down to 7 electrons each, so they have to share one to get their 8 to satisfy the octet rule. They'll become chlorine gas and they'll bubble right out of solution. This is one that you wouldn't want to do on the desk in front of you. You would need to do this in a fume hood, because chlorine gas is very poisonous. Now these two fluorines have acquired an electron, stolen an electron off the less active chlorides, and now they are F minus, and since they are now minus, they can be held in solution by the polar water molecule. Remember, to be in solution, to be aqueous, You have to have a charge so that the partially charged water can hold you in solution. What have the sodium ions done in this reaction? Absolutely nothing. The sodium ions would be spectator ions in this solution. Complete and balance this reaction. Well, in this reaction right here, we have the salt strontium bromide. It would be dissolved in water. It's aqueous, so we would have Br minuses floating around. Chlorine is above the bromine on the activity series, or if it's written horizontally, chlorine is more active than bromine. So chlorine will be able to replace the bromines, or the bromides right there, and we end up with strontium chloride aqueous. We would now have Cl minuses floating around. The chlorines would rip electrons off each of those bromide ions. Now the bromide ions would be, or now the bromine atoms would be down to 7 electrons each, and they would have to share one to become 8, and we would see liquid bromine precipitate from the solution. On this next one, will iodine be able to replace fluoride? That would be a no reaction. Iodine is the least active of the halogens on this list. Iodine cannot rip electrons off fluorides. That's not going to happen. That would be a no reaction. If you have any further questions or you need help, or if you would like to see this reaction drawn up here so you can understand what is happening, you need it in picture form, don't hesitate to ask. I'll be happy to post that for you if you would like to see it. Have a great day. Good luck in completing the rest of this assignment.